Hi everybody, this is Ms. Peachy from your WCA physical science class, and I just wanted to do a quick tutorial here just to explain and go over one of the questions from your study guide, because this was something we didn't have time to do in class, and you will have a similar problem on your unit test. So hopefully if you're taking the time to to listen to this or watch this today, then that will help you with this on your unit test. So this problem has to do with conservation of momentum. So we're looking at a conservation of momentum problem. And with conservation of momentum, I'm just going to write this on the board here, you're looking at the momentum of two objects before a collision and the momentum of the two objects after the collision. So you have two objects. Each object has its own mass and its own velocity. And then before the collision, the mass of I'm going to go ahead actually and make my pen just a little bit smaller because it's hard to write that way. The mass of object 1 is m1, and it's got an initial velocity v1, right? And we'll call these m1 initial, v1 initial. This tells me that, I'm going to try that one more time. I'll make sure this is very legible for you guys. All right, so we'll do M1 initial, V1 initial. This is just telling us that that's the starting velocity and the starting mass. And then I have to add together to that the mass of my second object, the initial, mass of, velocity of my second object. Also initial, okay? So these two momentums will give us the total momentum before the collision. This should equal the total momentum after the collision, which again would then, in this case, would be the mass of my first object also. I'll put F for final, times the velocity of my first object, the final velocity, plus the mass of my second object, final, times the velocity of my second object, final. Okay? So initial velocities times initial masses, initial masses, and you add those together for each object. That's object 1 and object 2. And that should be equal to the momentum of the first object and the second object after the collision added together also. Okay, so keep that in mind. So we have a 20 kilogram ball of clay. Write this underneath. Okay. Traveling east with a speed of 2 meters per second. So the initial velocity is 2 meters per second. Right? So that is its initial mass and velocity. We're going to add that to the mass of object 2, which is 30 kilograms. And this one's traveling west at a speed of 1 meter per second. Now, because the direction is opposite, the first direction was east, the second direction is west, so I'm going to call this a negative 1 meter per second, okay? And I'm doing this because that tells me the directionality is the opposite of the first one. First one was east, second one is west. In this case, I'm calling east positive and west negative. That just allows me to make sure that I cancel out where it's appropriate. So let's do just the left side right now. We'll kind of like simplify the left side. Okay, so 20 times 2 would be 40 kilograms meters per second, right? Plus 30 times negative 1, so negative 30 kilogram meters per second. So then when you add those two together, this is where that negative sign becomes important. because 40 plus negative 30 is just 10. So my total momentum on the left side before the collision is 10 kilogram meters per second. And we could say that is 10 kilogram meters per second traveling, because it's positive, we know it's traveling to the east, right? Okay, so after the collision, let's do that side. I'll do that in green. So here we have again the mass of object 1. So it says after the collision, they're joined together. So this is kind of a tricky part because they're joined together after the collision, that means their masses are now joined together. So we have to add those two masses together. 20 kilograms plus 30. We actually have just a single thing afterwards, which is 50 kilograms. Okay? And we only will have a single velocity afterwards. So we really aren't going to have this as much. We're just going to have a situation where we'll have one mass, which is the sum of the two masses, and one velocity, which is the sum of the two velocities. What we don't know is the velocity afterwards. We don't know v sub f. Okay? So we end up with 10 kilogram meters per second equals 50 kilograms times this v that we don't know. To solve for v, it's just a matter of using a little bit of algebra here. Okay. We have, let me simplify this without the units just to kind of show you guys what we have. We have 10 equals 50 v. So I took the units out just to kind of simplify it a little bit. So we just divide both sides by 50, right? This cancels. This becomes 1/5, or 0.2. And we know that before, our velocity units are meters per second. Okay? And again, because it's positive, we know it must automatically be to the east. Because it's a positive, we've already established at the beginning, it's to the east. Okay? Now, if you have, this is an inelastic collision. If you have an inelastic collision, you'll have, to start off with, you will have an initial and final velocity of each object separately, and then after the collision, they'll be combined, so you'll only have one mass and one velocity. And the mass, remember, will be a sum of the two masses because you're joining them together. If it were an inelastic collision, they bounced off each other and went opposite directions, you would have to contend with this part too. Okay? So an inelastic collision where they bounced off and kept themselves separately, you would have to contend with both the mass and velocity of each object separately after the collision. Okay? Hopefully that makes some sense and that helps you a little bit with this type of problem. They kind of all work the same. Really what you want to do, make sure you pay attention to those positive and negative signs, and make sure that that you kind of isolate your variables and solve for velocity here. That's what you're going to be probably doing in your test problem as well. Okay, if you still have questions on how to do this, if this still is confusing to you, I would advise you to email me and set up a time to meet so that we can go through another couple problems before you take your unit test. Thank you so much, everybody, and have a great day, and good luck on your exam.